Hi everyone, it's Mr. Glover here. Just about to get going on our next set of notes. So the whole point of today is to spend some time focusing on the quadratic equation or a quadratic function, but in general form. So we're going to focus on general form. We're going to talk about what you can do with it, why it's useful, and we'll solve some problems with all of our functions in general form today. So we're going to start out by just defining what general form looks like. Sometimes it's also called standard form. It's y equals ax squared plus bx plus c. Now, a, b, and c are all real numbers, and a can't be 0, because if a is 0, you don't have a quadratic, you've got a straight line. You can come up with any kind of examples you want. You could have an example like y equals 2x squared plus 3x minus 1. You could have something like y equals 1/2 x squared plus 0x minus 2. All of those are both of those are quadratics. So the three variables tell us some information about our function. A is going to tell us the shape of the parabola and the direction of the opening. So I would describe A as determining the shape and orientation of the parabola. Oh, there we go. And for example, shape and orientation of the parabola, if A is negative, then the opening is down. It opens down. B is going to impact the movement of the parabola. So I'm just going to say it influences the position of the vertex. There is a formula you can use with B to calculate where the vertex is, but rather than throwing a bunch of formulas at you, we're going to go through it in a different way. We're going to find our vertex by finding our zeros. C is going to represent the y-intercept of the parabola. And it's this idea that if x equals 0, C is all that is left. So if you've got a function and all your x's are 0, well, x is 0 on the y-axis, whatever number you have is your y-intercept. So we're going to take an equation. It's in vertex form. We're going to convert it to standard form, and then we're going to look and find some information about it. So y equals 2 or minus 2 times x minus 5 all squared plus 1. We can go and expand out these brackets. So we can call this minus 2 times x squared minus 5x minus 5x plus 25 plus 1. We can simplify the brackets. So minus 2 times x squared minus 10x plus 25 plus 1. Multiply by minus 2. So this is negative 2x squared plus 20x minus 50 plus 1. And then we can add the 1. So this is simply minus 2x squared plus 20x minus 49. So this equation, or this function, sorry, I'm kind of sloppy with my terminology. I really should be better about it. An equation is when this equals a number. A function is when it equals y. This is plotted for all different values of x. An equation only has one solution. Anyways, this function is the same as this function. So right off the bat, what can we tell? Well, if we look at A implies that the parabola opens down. And C is minus 49, implies that we have a y-intercept equal to y equals minus 49. You can't really take B and say, oh yes, the vertex is here. We don't have the formula for that. So on a calculator or Desmos, we're going to analyze this function, look at the maximum, the y-intercept, and the x-intercept. Okay, so I'm going to switch over to Desmos. We're going to plot our function. So the function is y equals minus 2 x squared plus 20x minus 49. So there's our function. And it does open down. Well, maybe we should double check that it has the right y-intercept. Y-intercept here is minus 49. We're good. What we're interested in is the maximum, the y-intercept, and the x-intercepts. So we've got a maximum here of 1. That's the y value. We have an x-intercept of 4.2, an x-intercept of 5.7, and a y-intercept of minus 49. So we can now go and we can write these out. It's actually, that's 4.3 and 5.7. So we have a maximum value at y equals 1. We have a y-intercept at y equals minus 49, and we have two x-intercepts. We have one at x equals 4.3, and we have one at x equals 5.7. Okay. So we're going to do this again with the graphing calculator or with Desmos. Then we're going to talk about how to do this without a graphing calculator. So we've got a new function. It's already in general form for us. We can find the vertex, the axis of symmetry, the direction of opening, and the y-intercepts and x-intercepts. So we're going to have to plot this one. We'll switch over to Desmos now. This function is not -2, it's just 2x squared. Minus 3x minus 5. So here's our function. We're interested in finding the vertex. The vertex is 0.75 and minus 6.125. So let's write this down so we don't have to keep going back and forth. Vertex is at the point 0.75 and minus 6.125. The axis of symmetry is just the x coordinate of this. So it's this x coordinate of minus 6.125. The direction of opening opens up. The y-intercept is minus 5. You can see this is our y-intercept. And our x-intercepts are x equals minus 1 and x equals 2.5. So we can go back now. We can fill in each of these different things. Our vertex is at the point 0.75 and minus 6.125. The axis of symmetry is just our x coordinate of the vertex. So it's x equals 0.75. The direction of opening opens up. The y-intercept is just minus 5. And the x-intercepts are x equals minus 1 and x equals 2.5. I suppose my y-intercept I should define as y equals minus 5. All right. So standard form is very useful because it allows us to easily find the zeros of our function, as well as the axis of symmetry. Okay, and now please be cautious. When I say zeros, I mean the same thing as roots. I mean the same thing as x-intercepts. So zeros are the same as roots, same thing as x-intercepts. Typically, we'll call it the roots of the equation. Those are the zeros or x-intercepts of the function, but they're three words that we just kind of use interchangeably here. To find the zeros, we are going to have to factor the equation. So we can factor it or use the quadratic formula, whatever you prefer. The axis of symmetry is halfway between the zeros. That was something I kind of purposely didn't talk about. If we go back to our graph, 1 0 is here, 1 0 is here, smack dab in the middle, that's where the axis of symmetry is. We can use the axis of symmetry to find the vertex. And you're probably asking, well, how do we do that? Well, you take your axis of symmetry, that's an x coordinate, plug it into your function, that'll give you the y coordinate, and now you've got your vertex. Now you know the max and the min. So let's take this function. We're going to do find all of these things by hand rather than graphing the function, okay? So we've got y equals x squared minus 7x plus 6, okay? Let's start by factoring the function, and maybe we'll keep a tally of things over here that we want to know about. So we're going to start by factoring the function. We need two numbers that add to minus 7 and multiply to 6, and those numbers are minus 6 and minus 1. Okay? So this is what it looks like in factored form, all right? So right now we know two pieces of info. From these factored, the factored form, we know the x-intercepts. We have two. There's one where the first bracket is 0, and that's x equals 6. One where the other bracket's 0, and that's x equals 1. So our x-intercepts are at x equals 6 and x equals 1, all right? We also know our y-intercept, and that comes from the constant. Our y-intercept is at y equals 6. Okay, so we've got two of the pieces of information. All right, the axis of symmetry is halfway between 6 and 1. So we could plot these points. Actually, we might as well fill these points in. Let's use a bright color. Let's use this blue. So we've got 1 and 6. All right, now for something like this, you might be able to count by hand, but for other equations, you might have a hard time finding the exact axis of symmetry. So if I go 1, 2, 3, 4, 5, there's 5 points separating them. So if I go in 2 and in 2 points, in 2 points, that gets me right here. Halfway between is half of 5, which is 2.5. Okay, so I know my axis of symmetry is on this line, x equals 2.5. If I wanted to calculate this, I can just take the average of these two numbers. I can take the maximum, I can subtract the minimum, and I can just divide by 2. So I can take 6 minus 1 divided by 2. That's going to be 5/2, which is 2.5. Or sorry, what am I doing? I'm going to add these. That's going to be 7/2, which is 3.5. Sorry about that. And 3.5, 1, 2, 3.5 is where our axis of symmetry is. So let's write that out. Axis of symmetry equals x equals 3.5. Now, we know the axis of symmetry, but I don't know where the function is. It could kind of go down like this. It could go down like this. I don't know the exact point, but I can find it. If I plug this x value into my function, I'll get my y coordinate. So we're kind of running out of room here. The vertex is at x equals 3.5. So if I plug this in, y equals 3.5 squared minus 7 times 3.5 plus 6. I can punch that into a calculator. That gets me a y coordinate of minus 6.25. what I've done is I've just found the y value at my vertex. I know the vertex is at 3.5, so if I plug it in, whatever I get out of it, that's my y coordinate. So I now know my vertex is at the point 3.5 and minus 6.25. And that's enough. I can now plot this function. So I can plot my vertex 3.5 and 6.25. Right about there. And I just connect the dots. You can fill in more points if you want, but I know that this is enough. You can just go like this. And there's my function. If we had time, we could always go and double check this looking on a graphing calculator or looking on Desmos just to make sure that that's what the function looks like. All right, let's do another one. Find the x-intercepts, the axis of symmetry, and the vertex for the following function. 0.5x squared minus 1.5x minus 5. So we've got a couple of different ideas here, a couple of different things we could do. We could just go straight into the quadratic formula, use the quadratic formula to find our zeros. That's completely fine. However, we can also try to factor out a common factor, and we might be able to do it by hand. So I'm going to just remove this 0.5. I'm going to divide it out. So I'm going to write it outside my brackets, and then I just have to divide each of these coefficients by 0.5. 1/2 becomes just 1, so it's 1x squared minus 1.5 divided by 0.5 is 3x, and then minus 5 divided by 0.5 is 10. So our equation turns into 0.5 times x squared minus 3x minus 10. So we've got to think, there are two numbers that add to minus 10, or sorry, add to minus 3 and multiply to minus 10. Well, 5 and 2 would fit the bill, minus 5 plus 2. So this is equal to 0.5 times x minus 5 times x plus 2. Right now, we've got our zeros. So we have, maybe we'll keep a tally over here. We have x-intercepts at x equals 5 and at x equals negative 2. So there's one of our things. We can now use our x-intercepts to find our axis of symmetry. The x-intercepts exactly halfway between them is where our axis of symmetry is. We can just add these together and divide by 2 to find the average. So axis of symmetry. Five plus negative 2 divided by 2. That's going to be 5 minus 2, which is 3, divided by 2. So this is 1.5. So the axis of symmetry, I guess that's the second piece of information. Axis of symmetry is at x equals 1.5. And it should be halfway between these points. If I got 7, I'd know something was up. All right, so now I've got the axis of symmetry. Now I just need to find my vertex. We're going to take the axis of symmetry, plug that in as x, and find the y. So y equals 0.5 times 1.5 squared minus 1.5 times 1.5 minus 5. Grab a graphing calculator, punch that in. And I get a minimum value of negative 6.125. Did I get the same minimum as my last question? Oh no, this one's just 6.25. This was 6.125. All right, so now we've got our axis of symmetry, we've got our vertex. It's going to be at the point 1.5 and minus 6.125. So now we've got our minimum value. I know that the function's opening up because I've got a positive leading coefficient. If I wanted to sketch it, it's very doable now. I'm not going to be very precise about it, but it's gonna look like this. Oh wait, no, it's not. My 1, 0 is at -2, my 1's at 5, so that's actually going to look like this. This will be -2, this will be 5. This is the point 1.5 and -6.125. My y-intercept should be -5, so this is the point -5. And there we go. That's what the function looks like. All right, one more thing. We also know that we can always write the factored form of a quadratic function as y equals a times x minus x1 times x minus x2. And x1 and x2 are the zeros. With this in mind, we can always find the equation of parabola if we know its zeros and we know one point it passes through. So essentially, we're doing the same thing we've done before in vertex form, except now we're doing it in general form. We're writing it in factored form, and then we're going to have to solve for our stretch. So graph of a quadratic function passes through the point 3 and 16, and the zeros of the function are x equals 1 and x equals -7, okay? So the zeros allow me to build the function in factored form. It's going to be, I'm going to call it the skeleton equation, just like we did last time. But I know that my function has to be of the form y equals a times x minus 1 times x minus 7. I know that because one of my zeros is 1 and one of my zeros is 7. So it's x minus 1 and x minus 7 because plus 1 turns this bracket into 0 and plus 7 turns this bracket into 0. What I don't know is my stretch. And the stretch I need to calculate. So to find the stretch, I need to use this point. I'm going to plug in 3 as my x value, 16 is my y value, and then I'm going to solve for my my stretch. So I'll use the point 3 and 16. Y is 16 equals a times 3 minus 1 times 3 minus 7. So 16 equals a times 2 times -4. 16 equals -8a. We divide by -8. -2 equals a. So I've now found my stretch. Once I know the stretch and once I know my zeros, I can plug these both back into my function. I can just solve for the function. So find function. Plug in my numbers in. Y equals -2 times x minus 1 times x minus 7. That's what the function is. If I want to write it out, this is factored form, but I want it in standard form or general form. Expand the brackets out. So -2 times x squared, outer minus 7x, inner minus x, last plus 7. So this equals -2 times x squared minus 8x plus 7. And it will equal minus 2x squared plus 16x minus 14. There we go. This function is the function that we described, and all we needed were the x-intercepts and one point. That point is often given to you as the y-intercept, and you've got to remember that if you're given the y-intercept, the x-coordinate of the y-intercept is always 0. But essentially, this is very much the same as what we did before. It's just we're working from factored form of the general form rather than working from the vertex and solving outwards. So I've got some questions for you to try for your homework. It's page 326, numbers 1 to 6, 8, and 9. You will find the first few questions are mainly just asking you to find things like your zeros, and then the latter questions are going to be ones where you have to put it all together to answer the question. But I think I'm going to end the chat here. So have yourselves a great rest of the day. I will see you all tomorrow. Actually, no, I'll see you all on Thursday in the meeting. So have yourselves, have a good day, and I'll see you all soon. Bye for now.